let me know whether you can share the screen we had. Let me check. Oh, yes, we can see your presentation, that you've started your presentation. Yes, we can see it.
Hello, everyone. I am very glad to be present at the conference. Let me present the result of our study on the topic eye tracking in the study of cognitive processes. Research was conducted at the Odessa Polytechnical National University by Vitaliy Pavlenko and me. Vitaliy Pavlenko is present at the conference too. The study of human eye movement and the trajectory of their movements releases the structure of the relationship of the individual with the environment, man with the world. Knowledge of eye movement and the movement is of great theoretical and implant importance. Exploring the possibility of studying the specificity of the many professions in order to increase the efficiency of the subject of labor. The process of acquiring knowledge is one of the central part of the learning processes. Proposed in the project method of psychological identification of individual on the basis of the experimental data using innovative technology, innovation eye tracking technology, and computational means of their processing, almost to monitor and diagnosis the state of cognitive processes during student learning activity. The COVID-19 epidemic has a preview effect of cognitive processes too. After the degrees, some cognitive function is decreased. The aim of our research is to develop software tools for building a non-parametrical dynamical model of human OMS and introduce of received information models in diagnostic practice of state of cognitive processes. The identification process is based on the use of the test visual stimuli that are displayed on the computer monitor screen in different distance from the starting position. On this slide, you can see the research processes. The developed software enable support such for tasks. The methods of psychological identification of an individual proposed in the project based on obtaining experimental data using eye tracking technology and computing means of processing them. Almost monitoring and diagnostic of the state of cognitive processing during the education activity of students. To describe object of unfollowed structure, it's available to use the most universal non-linear parametric dynamical models, ultra models. The input-output region for non-linear dynamical system with the unknown structure such as black box with one input and one output can be represented by discrete vector polynomial on degree n in Q3 in the form of this slide. Looking to account of specific of the studies OMS, test step signals are using indifference are using for identification. If the test signal X equals theta, where theta is the Heaviside function, that the partial components of the respondents Y first, second, and 2 will be equal of the transient function of the first order, H first and diagonal actions of the transcendent function on the second and third order H2 and H3 respectively. In the studies of the respondents, 3 experiments were performed equally for the 3 amplitudes. A1 is 1/3, A2 is 2/3, and A3 is 1 of the test with test signals in the horizontal description. The experimentals were organized in order to classify the subject in the state of fainting. The data for construction of the models or the OMS respondent on the same test signals were obtained using the TobyPro TX300 eye tracker at a different time of the day, in the morning and in the evening, after the walk, after the walk in the evening and before walk in the morning. The average values of the OMS respondents obtained from the eye tracking and various amplitudes of test signals in the morning and in the evening, you can see on the figure 3. On the figures 4 and 5, you can see graph of transient function for the state of respondents in the morning and in the evening models first and second. The graph of the transient function estimates for the in the morning and in the evening state of the subject based on the models are shown on the picture 6. The availability of the multidimensional transcendent function of different orders and for the approximation models of the OMS for the state of the respondent in the morning and in the evening is quantified using the induction. This is normalized standard deviation. To assess the psychophysiological state of personnel based on the OMS models, studies were carried out. First, getting a feature space for building a human state classifier using machine learning, building classifier using determinational and state learning methods for pattern recognized based on the data obtained using eye movement tracking technology. Gaussian classifier is built for separate the two classes and discriminant functions was using in this form. A Gaussian classifier of a person fitting the state in a two-dimensional feature space is provided with the maximum recognized reliability with combination of following features. These features you can see on this slide. The application of the OMS identification method based on the water models in the form of multidimensional transitional function using test visual stimuli with different distance from the state position, step function in different amplitudes is substantiated. The information technology of updating the experimental data for the indication OMS with the help of test visual stimuli and the use of eye tracking to track the corresponding eye movement has been developed. Developed in the MATLAB system software for the identification OMS. Experimental studies OMS were performed with the help of eye tracking technology and the transient function of the first, second, and order were routines on the base on the oculographic studies. Classifiers of human cognitive states are built on the based on the study heuristic features that are resisted to computational errors. The features were calculated on the multidimensional transcendent function obtained from the integral Volterra models of the human OMS with a few approach of diagnostic human cognitions. Thank you very much for your attention.
Thank you, Tetiana, for your presentation and for your research. I will like to invite you to ask questions.
Can I ask a question?
Yes, Vyacheslav, please.
Yes, thank you. Thank you, Tatiana, for your presentation. My question is, you used eye tracking technology, eye tracking tool to compare two cases, as you called in morning and in evening. Yes.
Yes.
Could you explain what is the sense of such comparing and which the main task of your cases? You researched the eye motion using eye tracking tool for that for which goals?
In our research, we research fading in the morning and in the evening because it's one is cognitive processes which we can research very easy in the during one day, in the morning or in the evening. That is why we can analyze the result and use this result for later operation.
Okay, thank you. I understood that you used the two cases in morning and in evening. Yes, you use these two cases to compare attention or any other issues in cognitive process.
It's will be our future researches. Because the main task was to build the model of OMS and research this model. And in our few research, we have the plans to research our other cognitive processes.
Okay, and if it's possible, last question: how many participants participated in these experiments? Because when we use eye tracking, usually it is one of the difficult tasks how we can assure representative set for participants.
Thank you for your question. I really agree with you. We had some problems with the experiment. This experiment was at the Lublin Polytechnical University, and after this experiment, we had 8 elements in the training set, and these 8 results.
Yes, my question very simple. How many participants? Sorry for repetition. How many participants participated in this experiment? How many participants of your experiments? Because if we use eye tracking, we need to use 5, 10 or more participants to get objective results.
Vyacheslav Sergeyevich,
Да.
you mean quantity of
Yes, quantity of participants in this experiment.
Well, I said that we have 8 participants.
8, thank you.
Okay, 8 participants. Okay, thanks. And I would like to ask Tetiana, where did you get the software for this eye tracking? Where did you get this eye tracking software?
We got this software at the Lublin Polytechnical University.
I see. Yes, I can. Okay, thanks a lot. If there are more questions for Tetiana? If not, then thank you very much for the presentation.
Thank you too.
It was very nice to see you and hear your ideas. Okay, our next presenter is Oleksandr Gordieiev, Daria Gordieieva, Vyacheslav, Kharchenko, and Ievgen Brezhniev with extended model of software quality assessment scenario, concept, operations, and applications. Do we have our presenter here with us? Oleksandr
Yes, I am
Gordieiev.
Oleksandr Gordieiev.
Okay, Oleksandr Gordieiev, please, you can start your presentation, but maybe, Tetiana, would you be so kind to stop sharing the screen, or I will do it.
Do it, but I stopped.
Okay, probably I did it. Oleksandr, can you check whether, oh yes, you can start, your presentation starts.
Okay.
Yes.
Dear colleagues, my name is Oleksandr Gordieiev. I would like represent our work together with my colleagues, with Vyacheslav Kharchenko too. Software quality assessment is a mandatory process ensuring the required software quality as part of a whole software development process. We conduct development of existing information technologies and emergence on your information technology, artificial intelligence, cloud computing, etc. A system increase requirements of the assessment process, software quality assurance. Next, this evolution among the existing approaches and paradigm software quality assessment has influenced dynamics as there significant problem, including weak formalization in the planning software quality assessment tasks. Next, a high degree of unequality in decision making by responsible participants of the process, lack or access on assessing additional information, and last, information of participants group software quality assessment process. Some words about related work analysis. One of existing approaches that we formalized software quality assessment process to a required level in the scenario approaches. The analyst works on the organization formalization software quality assessment process, describe some cases in the development software quality assessment process, and scenario approach is described in part of level some elements. Their works in scenario approaches, but is considered general as approaches to management without taking into account the specific software quality assessment in general. The scenario approach is not conceptually considered in the work of software quality assessment based on the software fault injection. In some papers, software quality assessment scenario models considered in general, but it does not take into account important features of a process. The goal of the work is to develop an extended model of software quality assessment scenario, which take into account its elements, features, and change, etc. You can see formalized model, graphic representation, and formal description of this model. This model includes a set of initial conditions software quality assessment scenario, set of input data with software quality assessment scenario, actions, transition data is transmitted from action to action. Corrective factors would clarify actions, transaction from action to action. Next, the roles, this one, end result of a software quality assessment scenario. Experimentally, it was found that the scenario during this life cycle, this one, involves and represented in the following three processes. First, forming a scenario on paper, next, forming of a pilot scenario, and next, formal a real scenario. And as a result, in the following three states. First, a scenario on paper, next, a pilot scenario, and last, real scenario. Thus, we will refine the general record to the software quality assessment scenario based on the state of a scenario and add a variant of scenario, VOS, this index for each set which indicates the state of scenario. For example, scenario on paper, of assessment quality of software, pilot scenario, and real scenario. Sorry. Next, operation of a scenario. During this life cycle, the scenario can be refined, modified. It was found that such changes can be reduced to following two operation scenario elements. First operation, exclusion a scenario element, and next operation, inclusion, adding a scenario element. A scenario element conversation operation is also possible, but is not considered because a pair of exclusion-inclusion operation can represent it. Then enter the additional sets of each of them, index TEOS, type of elements of scenario, was added, which indicated variant of scenario. Index TEOS can the following values: inc, initial condition with scenario, int, etc. Formally, we present the description of operation of exclusion and inclusion. To do this, enter following aggregation some sets. For example, set of initial element from corresponding set. Next set of elements is that are excluded from corresponding set, and additional subsets to this model. In general, the operation exclusion, deleting element, and the operation inclusion addition for each state with scenario are written follow this one. Consider the variance for inequalities at the level of elements of a scenario on paper and pilot scenario, and present them qualities simple search, including variant of complete quality. For example, we have all variants inequalities of elements scenario on paper and pilot scenario, and for example, one such variant table line 22 will be described in more detail. This variant consider following ratios. This one. Since inequalities with scenarios indicate the use of operation inclusion or exclusion, we will represent in more detail following inequalities both operation. For exclusion, this one, and for inclusion, this describe this operation. Application of a model. The represented model, proposed model, can be used to access the software quality using software fault injection. For example, in particular, development and implementation fault injection testing, which used research production corporation RADI. Next, we perform fault injection. Various profiles of defects are formed, which are injected in the electronic project. And next, it should also be noted scenario approaches application for software user interface usability assessment with eye tracking. And next, extended model of a software quality assessment scenario can be used for applied intelligence system as to class information system. It's all. Thank you very much for your attention.
Thank you, Oleksandr, for the presentation. I'm asking my colleagues, maybe there are some questions for our presenter, for Oleksandr. If not yet, Oleksandr, may I ask, probably your work is, well, you've started it some time before. Does the COVID situation affected it somehow? Well, I mean that we have to live in a distant mode now. Does it influence your work and your ideas in any way?
You mean about which model which I
Yes.
represented? No, each model not for COVID only. This model for software quality assessment in general. I can say that model more unified model for such process for software quality assessment process.
More okay. It's okay. Thanks a lot. I understand. Thank you, Oleksandr. Maybe there are more questions for Oleksandr from our guests and colleagues. Well, no more questions, Oleksandr. Thanks a lot for the presentation.
Thank you.
Thank you. Thank you very much. So our next presentation, our next presenter are someone, maybe Sergei Lavrov, Yuri Shmelyov, or Ruslan Yakovlev. Are they here somewhere, those authors, with the topic optimization of helicopter aircraft engine working process using neural networks technologies? Sergei Vladov, Sergei Shmelyov, Ruslan Yakovlev. And not yet. Maybe they have some technical problems and will join us later. That is why I have to skip to the next presenter and ask maybe Anastasiya Karpyak and Olga Rybytska are with us.
Yes, I am. Hello.
Okay.
I'm happy that I joined earlier. So nice to meet you. My name is Anastasiya Karpyak, and I want to show you my presentation. Give me 1 second. Just let me know how to share the screen. Oh, okay. Which one screen? Maybe this one.
And we can
sure
see. Yes, we can see your presentation.
But I can't see it. Not this one. Stop share. 1 second, because it's not my computer. In my computer, my kids throw water on it, so I used my husband's computer, and it's complicated for me.
We understood that you cannot be Andrei Karpyak. That is why.
It's written. Yes, I am Anastasiya Karpyak. Sorry, I was sure that I connected like Anastasiya, but
it's okay. It's okay.
This one presentation. Okay, I tried to close this one and to use, and he has 2 screens, and I hate 2 screens. Share screen, maybe.
We will tell you what we see, but
yes, you shared. Yes, this one. Super.
Yes. Okay.
Now we need slides. Yes, from big home. Big screen. Okay, it can be like this one. Okay.
But we can, maybe you shared the screen, but we can't. Well, we can't see the presentation. We just see the PowerPoint. If it's okay.
No, it's PowerPoint presentation, but.
I mean, but we see that it's in edit mode instead of presentation.
No, not this variant. Andrejko. Animation slideshow view.
No, yeah, well, slideshow is good when you press the start slideshow, but you shared the PowerPoint, not the slideshow. Maybe if
this one, it's okay.
Yes, it is. It is.
Super. Cluster analysis of motivational management of personal support of IT companies. Me, Anastasiya, Karpyak is representative, and Olga Rybytska also wrote this article. All of us are from Polytechnic National University. Next. Oh, introduction. The proposed results are part of a study devoted to the analysis of the causes of staff shortage in Ukrainian IT companies in ways to solve all of them. And the article examines the motivational component of business models of IT companies in Ukraine, like compensation, working conditions, career, project, loyalty, and general consolidated index. The research was conducted by cluster analysis of statistical data hosted by companies on the platforms Dow, Glitch, and LinkedIn. Cluster analysis of the mentioned indicators with the addition of data of the scale of companies. Ukraine is a supplier country for human capital. It's pity, really pity, but in 2021, the IT industry received a record growth, plus 37%, confidentially reaching first place in terms of export of services. So IT services is 37% of all export of services in Ukraine. The growth of the IT industry is projected in the future. It was projected before the war, but staff shortage are significantly hampering this development. In 2021, more than 1,1200 vacancies were published on Dow platform, but feedback on vacancies is rapidly declining. Most vacancies remain unfulfilled. Now we have just a little different data, but 2 months ago it was this situation. The management of IT companies must satisfy their staffing requirements based on the internal reserves of available human capital. The reasons of the lack of skilled workers in the field of information technology in general are discussed on numerous platforms. However, the global problem cannot be solved quickly, in particular due to the large-scale invasion of the Russian aggressor in Ukraine. The desire and economic need to hire the best professionals in the face of growing competition gives them freedom to choose, give freedom to employees to choose the best employer. Employees of IT enterprises become pioneers among employees of other industries, for whom the work is personified with a certain occupation, with a business and as a whole, and not with attachment to a particular workplace or organization, regulated working hours and organizational hierarchy. IT is different one. Given the crucial role of professional qualities of team members and the growing competition of IT companies, employee motivation is becoming a crucial factor in forming, maintaining, and building a team. That professional and human qualities involved in the teams of specialists come to the fore and become an integrated part of the company description in the IT market. Results of an anonymous survey of employees of the IT enterprises in Ukraine. It was published in platform jobs.ua. We analyzed this survey, and we analyzed this survey by 5 main indicators: compensation, working condition, career, project, and loyalty. We used to analyze this information, to analyze this survey, we used the clustering method. Clustering is a division of a set of objects into subsets, clusters that do not intersect to combine into separate groups, the most similar to each other. Objects that differ significantly due to the clustering will belong to different clusters. There is high probability that the input data will not be clearly distributed between clusters, and as a result, the separation obtained by using the elbow method will not correspond to the highest score of breaking quality. That's why we propose to combine this elbow method with simplified silhouette method. You can see this elbow method and the silhouette method. The results of the elbow method and the method of estimating the silhouette of finding the optimal number of clusters get us to to the division. This information wall data we divided into 5 clusters, and this 5 clusters is considered optimal. You can see this one, 5 cluster, and here as well. Experiment and results. Due to the lack of some indicators on all IT companies registered in Ukraine, the authors, so we focused on our research on 236 brand companies, for which we managed to collect complete information of the mentioned indicators of motivation, the scales of company, and the percentage of employees in Ukraine, and on the mentioned platforms in personal profile files. Nobody knows in Ukraine how many IT companies do we have. Nobody knows the exact number. We have this problem, but 236 brands, we somehow collected data about them. So they are the biggest one. First of all, we clustered by categories: employee satisfaction index, this is OX, and compensation OY. We got these 5 clusters, and the results. Clustering by categories of employee satisfaction indices. First cluster, cluster 0, first cluster 0. I don't know why, but it all time when we use clustering, the first cluster is 0, 1, were 55 companies with the highest performance in all indices. And the second one is cluster 1, and we have 94 companies with higher than average satisfaction index. And the other cluster number 2, it was formed by 60 companies with average employee satisfaction indices, and cluster 3, 25 companies with lower than average employee satisfaction indices, and cluster 4 only with 2 companies, Playtech and Ubisoft, with the lowest rates. And in all other clustering, we have the lowest rate for Playtech and Ubisoft. We also clustered by, in other measures, we clustered by scale and employee satisfaction index. So also we have here the number of employees, and here we have the number of employees in hundreds. And on OY axis, we have consolidated index average value. So you can see most of them are here. And the results, the highest and the lowest are indices of satisfaction of employees of enterprises with the smallest number and with a large percentage of Ukrainian employees. And employees with more than 700 employees rated satisfaction as average. Exceptions are these companies, Ubisoft and Playtech. But in companies Ubisoft and Playtech, we have not many Ukrainian workers, 3% and 26%. It's not a big amount of Ukrainian workers in these companies. Clustering by satisfaction indices and enterprise scale. We also cluster this information. We have OX satisfaction indices, and Y enterprise scale. Our figure illustrates that facts that more than 85% of employees in almost all Ukrainian IT companies are satisfied with wages. It's a big amount, it's a huge amount. Exceptions are the large company Ubisoft, one more time, with only 3% of Ukrainian team members, and the medium-sized company Playtech, 26% of Ukrainian team members. Illustrations of the relationship between the percentage of Ukrainian workers and other categories of satisfaction indexes are similar. The lowest average for enterprise with a high share of employees registered in Ukraine was recorded in the category career growth. because when you work for international employee, you do not have a good career growth. That's why they're not satisfied in this industry. And the discussion. The joint clustering of this data showed a significant relationship between the percentage of Ukrainian employees in the company and all satisfaction indices, without exception. Those companies with a high share of Ukrainian employees show a high level of salary satisfaction. Joint clustering, according to the same indicators, proves the independence of the project satisfaction index from the percentage of Ukrainian employees. Only companies with more than 80% of employees registered in Ukraine show high satisfaction with working conditions. Career satisfaction is slightly lower. We talked about it earlier. So the conclusion, the study allowed us to conclude that large IT companies with a high and significant share of employees registered in Ukraine carry out motivational management at the appropriate level. Companies that almost 100% Ukrainian team members show the highest level of satisfaction in all indexes. Specialists in the Ukrainian IT industry are well motivated. Lack of motivation isn't a deterrent to the potential growth of the industry. The result confirms the prepared and published conclusions of the Center for Economic Revival. And we know that the reason of the lack of skilled workers involved in the field of informational technology lie on other fields. We think that in the educational one. Why we think that not motivation but education? Because we checked a lot of revivals, and educational part is significant problem in developing IT industry in Ukraine. We have lack of professionals because our university and courses didn't give enough of people who is able to work on IT sector. Any questions?
I see what you, I understand your results, understand your conclusions. Okay, maybe there are some questions. Vyacheslav, Kharchenko, I believe you have a question.
Yes, thank you for possibility to ask. Thank you very much for your very interesting, in my point of view, report, because I'm head of department of IT and work in IT. My question is, what about your research in context of different groups of IT specialists? I mean, it is a junior or middle or more high level IT specialist, in comparing with different targeted group of students. When students started their work, and after 1 or 2 years later. Hence, the question is about possibility cluster analysis of a different targeted group. I mean different students group, different position in companies and so on. Thank you.
I don't know, because I used collected data in site jobs.ua, and when you check this anonymous way, there is no information about that is this worker is a junior or middle or senior. So I can't divide this collected data into the groups, but according to situation on IT labor market, I can say that we have a huge problem with specialists in the middle and on senior level, but we have enough of specialists in level junior and like trainee. So trainee and junior, we have a lot of people who want to go to IT market, but not a lot of vacancies. But talking about open vacancies on middle and senior level, it's really complicated to fulfill these vacancies.
Thank you so much.
Not at all.
Thank you. I know how to improve the whole situation with education in IT. We should, well, the government should, how to say, should admit that the education in IT is a part of IT branch, and our salary, well, those who educate in IT their salary should increase to the level of the average level of salary in the IT. Then maybe some positive changes will appear.
Yes, and we wrote another article, and I hope it will. In the Polytechnic University, this Vysnik Lytvyn Polytechnic, we wrote article about IT and education and IT, and we have researched that we can't fulfill enough, or we can't fulfill enough students for work in I need to recombine this phrase. Like we need 10,000 workers, but using our proper condition, we can teach like 50% of needed personal staff. So we have a big problem, and education is maybe war, maybe right now the war, because Kharkiv is one of the biggest IT centers in Ukraine, and war and lack of students in IT specialties is the biggest problems of further IT growth in our country. But this is the situation.
This is the situation. Well, we will work something out as soon. Well, we are working something out, although the war is still ongoing. But we are. This is our field of fight of IT educators.
Thank you. Thank you.
Okay, thank you, Anastasiya. Thank you so much for the presentation and the discussion. Thanks a lot.
Sorry, I forgot about last slide.
Okay. Thanks a lot.
Okay, thank you.
Okay, thank you very much, Anastasiya. Thank you very much. And let's go for our next presenter. The topic is a method of determining the fractal dimension of network traffic by its probabilistic properties and experimental research of this method's work quality by Anna Drieveva, Oleksandr Drevyev, Yelizaveta Maleshko, Mykola Yakimenko, and Volodymyr Mikhav. Do we have any of those authors here with us? Anna Drieveva, Oleksandr Drevyev, Yelizaveta Maleshko, Mykola Yakimenko, Volodymyr Mikhav, and maybe not yet, maybe again some technical problems. What about the next presenter, Oksana Pichugina? I'm not sure whether those participants are here with us. Oksana Pichugina, I can see you in the list of participants. Will you be able to start the presentation, Oksana? I can see you, but we cannot hear you. Although I see that your microphone is on, but we can't hear you. We can see you, but I can't hear you. Can you, Oksana, hear us? Yes, you can. But somehow we can't hear you. Maybe some microphone. Yes, you're here, but we can't hear you. I have a proposition, Oksana, maybe you will need some more. Yes, maybe Oksana, if it's okay with you, I will ask the next presenter and you will be the next after him, if it's okay. Okay, so we will be waiting for your coming back, and meanwhile, I would like to ask, maybe, you have two presentations, Oksana, then definitely please restart the computer. Maybe Volodymyr Petrinic and Dmytro Petrenyuk, you used to...
Yeah, too.
Yeah, very good. I'm so glad. Can you please start the presentation? Will you be able?
Would you like to demonstration of screen?
You probably can demonstrate the screen. Yes, you can do this. Can you?
Are you see my?
No, we can't see your present. No, you are not sharing the screen, Volodymyr.
No, I didn't know.
Or maybe something. Yes, we can see your presentation. It's in power. We can see the PowerPoint. Yes.
May I begin? Are you here?
Yes, we can see the presentation, the PowerPoint. We can see it. The first slide, second, third, fourth. Yes.
I am Volodymyr Petrinic from Central Ukrainian National Technical University. It's Kropivnitsky in Ukraine. My so-author, my brother Dmytro Petrenyuk, absent. Now I'm from you. From my report has name application trend through 3 minimal and projective planar 2 minimal graphs. We are aimed to application of our results in various areas as linguistic management, social management, or educational, and others. Our results has theoretical means. First of all, problem consists of task and method of solving. Task is following: to demonstrate the possibilities of the phi method for the construction of the set of all non-isomorphic 3 minimal planar sample graphs in which the set of all vertices is located on the boundaries of 3 true cells, and constructing the set of all non-isomorphic 2 minimal projective planar graphs in which the fixed set of points is located on the 2 boundaries, 2 cells or pseudo cells. Method of solving is following: the mathematical method phi transformation in which large structures are regarded as a set of small and simple substructures. For this, they may have some common parts that can be identified and amalgamated when constructing or reconstructing an entire structure from a finite number of substructures. The second slide contains the main results. First, first result based on the method of fit transformation graphs of the 3 minimal planar graphs and 2 minimal projective planar graphs have been established. Second result, modified algorithms of producing these graphs have been suggested. This algorithm have a polynomial time nature. First, third result, polynomial algorithm of construction and list of the 3 minimal planar graphs in which the set of all vertices located on the boundaries of two cells. Fourth result, polynomial algorithm of constructing and list of the minimal projective planar graphs with genus 0 or 1 in which the fixed set of points is located on the two boundaries, two cells or pseudo cells. Next slide contain application trend. First of all, we presented an example of possible application is the set of points placement problem or automatic control with subsequent access to its points. Second, if we talk about the surface as an almost infinite set of values of the function of several variables on a given finite subset as a set of vertices whose relationship between pairs of elements as a set of edges, we have an almost embedded graph in the surface. Said, if it is possible to set edges as an almost infinite subset of points, and in the absence of intersections of graph of edges in interior points of edges, we will have an almost exact embedding of the graph in the surface. Fourth, if the surface is spherical or resembles some extent of plane without holes, then use the following list of 3 minimal graphs, planar graphs on place on the boundaries of 3 cells of all vertices of the graph. If the surface is a sphere with a hole or to some extent resembles a plane of holes, then we use the following list of 2 minimal projective planar graphs to place on the boundaries of 2 cells of a given set of vertices of the graph. Application trend 2. We say that the structural properties of complex system model presented in the form of a graph model can be studied using a simple graph with a fixed set of points embedded in the surface in which the edges of the graph will be located where surface is a Euclidean plane or projective plane. The point is as a vertex or inner point of graph or of edges of graph. Our results will be useful in the systematic analysis of both graph model and their topological aspect, which we have common properties at the edges and vertices of the graph model. The solution of our task was based on the method of graph transformations whose founder is Mykola Pavlovich Kharchenko, and the concepts he introduced. The recognition of fit transformation of graphs has been taken from reference number 1. About 3 minimal planar graphs and about non-cylindrical graphs. First, according to reference 3, we will consider a simple graph to be a planar graph having the following properties. First, 2 cells at the boundaries of which all vertices of the graph are located. 2, removal of any edges or its pinching into the point of this edge leads to the destruction of properties 1. According to reference 2, we define a non-cylindrical graph as a flat integrated graph having more than 2 cells of the cylindrical graph on the boundaries where all the vertices are located. Whereas removal of any edges of cylindrical, non-cylindrical graph or a square rise in the point of this edge leads to the distribution of all the graph vertices on the boundaries of 2 cells of the cylindrical graph. We solved the problem. Let us study the identity problem is very simple. Let us study the identity of non-cylindrical and 3 minimal density graphs and compare the graphs from the given list of graphs in figure 1 with the list 2, with the list from reference 2, and the modified algorithm of building all 3 minimal planar graphs. And we have the following relation. For this problem, we have the following relation for the planar graphs. Proposition 1, all graphs from the list of graphs in reference 4 are in the list of graphs in reference 2. Non-cylindrical and 3 minimal graphs are equivalent.
Okay.
And the graphs theta under 6, theta under 7, k under 5, k under 3,3 from the list in reference to are absent in the list number of list of graphs in reference 4. Modification algorithm. We consider the modification of algorithm in reference 4 for constructing 3 minimal planar graph, which was based on the inexact result of characterization of planar graphs with all significant edges with respect to the number of auxiliary multiplicity of vertices equal to 3 at the operation of removal and remaining edges. The main idea of that such graph have at least one homomorphic graph subgraph of graph, and at most three these graphs. It is necessary to define the nature and possible variants of combining them. About 2 minimal projective planar graphs. Task which we have to construct the set of all non-isomorphic to minimal projective planar graphs in which the fixed set of points is located on the two boundaries of two cells or pseudo-cells. Similarly, of this task was the task for graphs with a number of vertices less than 10 on various genus, which solved in references 6, 7, and 8. Introduce a new characteristic that measures the sum structures of the set X and points of graph on surface S. Proposition 31. Each projective planar subgraph with a given set of points that are not located on the boundary of one's two cells, through cells, or pseudo cells of an arbitrary graph obstruction of the projective plane can be represented as a subdivision graph K under 4 or a phi image of a pair of graphs homomorphic to graphs from the set which consist of K under 5, K under 3, 3, and K under 4, and K under 2, 3, and last element K under 5 without one edge. When identifying pairs of points from the connection set, both in pass and in a cycle. That's all. Would you like to send your questions as a text to email? Now, email
Yes.
Petrenyuk .ua. We will be very glad to prepare our answer to you as soon as possible.
So,
Thank you
okay,
very much.
thank you very much. So if we have any questions, then we can send it by email, by this email we have on the screen, and we will have the answers. Okay, thank you very much for the presentation.
Thank you very much too.
Yes, yeah, we can see how we can have our answers. That is why we can contact you on this email. Thanks a lot. Thank you very much.
Thank you very
I
much.
can see, yes, I can see Oksana Pichugina is here with us. Oksana, can you try to say something, please?
Okay, hello, do you hear me?
Yes, 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 yes. Yes, we do. Yes, we can hear you. You can start with the presentation. Please let me know, would it be the one where you with Olga Matsy or yours when you're the only
What
presenter?
presentation I will deliver?
You will deliver. Okay. Okay, then we will stop. Volodymyr Petrinic, be so kind to stop the